All right, number 6, it says let f be a function defined by, or in the closed interval, -5 to 5. Notice it's a closed interval, at least what's given, where f of -1 is 3. The graph of f prime is given. Part A. We're not going to be doing too much with semicircles this semester, but next semester we're going to be dealing with how that relates to the integral and the derivative. Part A. For the open interval -5 to 5, find all x values for which f has a relative max. When does f have a relative maximum? When f prime changes signs from positive to negative. So, and we don't have to consider endpoints because, why? Part A has an open interval. So where does it change from positive to negative? So we would say f has a local max when x equals -3 and 4? Is that what you guys said? 4. Since f prime changes signs from positive to negative. I would do it that way, just so there's absolutely no doubts. Okay, at these points. That's it. 2 points, so you're going to get 1 for the correct answers, 1 for the correct justification. Okay. Any questions on part A? Yeah. Is in what? At x equals 1, there is extrema, but in part A, it was asking for a relative maximum. At x equals 1, what do we have? Relative minimum, right. So, yeah, pay attention to the words. Part B, over the open interval, -5 to 5, find all the x values for which f has a point of inflection. When does f have a point of inflection? When a point of inflection is when f changes, that's the words, when f changes concavity, or when f prime changes direction, or when f double prime changes signs. Since we're looking at f prime, we're looking at direction, but that's not good justification. What do you have to include with the justification? Changing from increasing to decreasing, or decreasing to increasing. Okay? So I'm going to be as thorough as possible. So when do we have a point of inflection? -4, -1, and 2. So we'll say f has a point of inflection when x equals, I'm going to separate the justifications here. So when x equals -4 and 3, since what? Oh, 2, yes, thank you. I'm looking at it at an angle, so it looked like the high point. Okay, -4 and 2, since f prime changes direction from increasing to decreasing. And when what? X equals -1, since f prime changes direction from decreasing to increasing. And I know that's a lot of words and you're trying to shorthand it as much as you can, but that's not a good idea. You want to be as thorough as possible so that when somebody's reading it, there is no doubts what you're saying, so that you don't miss stupid little points because of language issues. Okay? So that's that. 2 points. So again, 1 for the correct answer. So you have 3 answers here. 1 for the correct justifications. Any questions on B? Okay. C. Find all intervals on which the graph of f is concave up and also has a positive slope. For it to have a positive slope, what does that mean? F prime is... If it's got a positive slope, that means f prime is positive. If it's got a positive slope, what does that mean about f? It's increasing. If f has a positive slope, that means the function's increasing, which means f prime is positive. Remember, what's another word for slope? Derivative. So if f has a positive slope, it has a positive derivative. Does that make sense? So, when do we have... first, when is f concave up? Can I get rid of A and B? Yeah. All right, so C. F is concave up. Let's see. F is concave up. When? What are we looking for? When f prime is increasing. Therefore what? Where is it just concave up? -5 is less than x is less than -4. Where else? Negative what? -1 is less than x is less than what? 2. Okay. F is concave up when f prime is increasing. So these are the intervals for when f is concave up. When does f have a positive slope? F has positive slope when f prime is positive. So therefore, -5 to -3 and 1 to 4. Okay, but that's neither one of those are the questions specifically. We're looking for when it's concave up and increasing, essentially, right? So, yeah. Well, I'll show you what you have to write completely. So when is this concave up and increasing? -5 to 4. So we'll say -5 is less than x is less than 4. And 1 to 2. Okay. And 1 is less than x is less than 2. Is that it? We're looking for when f prime is increasing. Oh, -4. Thank you. That would have been bad. F is increasing, so when f prime is increasing and f prime is positive, so above the x-axis and going up. So those are the only two places. So the overall justification is what? Since f prime is increasing and positive, yes, over these intervals. That would be good enough. So honestly, that's enough. This is just me showing you what you're looking for, right? So you're looking for when f prime is increasing and positive. So how many points is this worth? 2. So you're going to get 1 for the intervals and 1 for the justification. Okay, part D. Let g be the function. Let me write this down. G of x is what? 2f of x. Okay, so that's the function we're working with. Find an equation for the tangent line of g at x equals -1. So what are the two things you need for a tangent line? A slope and a point. But what function are we looking at? G. So there's two things we need. We need G prime of, well, we need G prime of -1 and G of -1. Those are the two things we need, right? Okay. So now, before we can find G prime of -1, we got to find G prime of x. So let's take the derivative of this. G prime of x is equal to what? 2 f prime of x. You could have done the product rule, but 2 is a constant, right? Take the constant out. What's the derivative of f? F prime, bring the 2 back in, so 2f prime. Now we can plug in. So G prime of -1 equals 2 times f prime of -1. So since I gave you f prime of -1 in the graph, we would say 2 times -2. You guys see that? So when f is, or when x is -1, f prime is -2. So G prime of -1 is -4. And then the other thing we need is G of -1. So how am I going to get that? Up here, right? So it's going to be 2 times f of -1. Uh-oh. What's f of -1? It was given in the original part. So f of -1 is 3. So times 3. So G of -1 is 6. And so now I want my tangent line. Is that what this says? Okay. So it'd be y minus 6 equals -4 times x plus 1. 2 points. So my guess is that the one point is getting G prime of -1, and the other point is the tangent line itself.